All right, what's given there for each of these graphs, obviously is not the graph, but it's just the period, okay? The thing is, if your period is incorrect, then your graph's not going to be right either, and you can't check it correctly on the graphic calculator, okay? So now we can look at quite a few of these. We can go over with them with the calculator if we need to. All right. It said on number 9, it's 1/2 x. Okay. Now, notice, all right, like on about half of these, like 41 and 37, all right, 13 and 11, those aren't in terms of pi, are they? Okay. So what happened on those is the coefficient was in terms of pi. So when my coefficient is in terms of pi, my period will not be in terms of pi, and vice versa, because the pi's are going to cancel out. All right. Because the pi's are going to cancel out. Yeah, when you do on 37, the coefficient is 2 pi, so it just cancels out. And it just gives you 1. Yes. All right, like a fraction coefficient. Yeah. I think the very first one had a fraction. Our number 15 did. Let's do number 15. It was a little bit more challenging, okay? Yeah, period was 6. All right, now, so let's go through the whole thing on number 15 here. If y'all want to come up here and grab that, you can. All right, so on 15 you had negative sine of 2/3 x. Okay, so when you have a fraction for a coefficient, it does make it a little bit more complicated to calculate what the period is. All right, amplitude here, well, we don't see a numbers, but what's understood there though? 1. And we don't say -1, do we? Because it's the absolute value. All right, the period, the way we do for sine, cosine, is we do 2 pi divided by b. And this is where b is that coefficient in front of my x there. So what's my coefficient? All right, 2/3. All right, so 2 pi divided by 2/3. All right, so let's figure this out. How can we divide this? Yeah, multiply by the reciprocal, which would be 3/2. Okay, now look what's going to happen when I do 2 pi times 3/2. The 2's cancel. All right, so I got left pi times 3, which is 3 pi. Now, let me show you something that I didn't really show you yesterday, okay? You know how, well, we count out to 4, and the last one that we do will be 3 pi, right? And then we half it and half it again, all right? Another way to do that is think of it this way. The period is going to be divided into 4 equal units, right? So what you could do is just take the period and divide it by 4, and that would tell you what each one is counting by. Okay, so how would we do? What's 3 pi divided by 4? 3 pi over 4. So every unit is 3 pi over 4. Okay, now that's one way of doing it. I like the halving strategy. Okay, because you don't have to really do any calculations when you half it. All right, not any hard things. So we've got 1, 2, 3, 4. So this last one's got to be what here? 3 pi. Okay. All right. What's half of 3 pi? 3 pi over 2. Okay. Now it works a lot better when this number's even, isn't it? All right. But if it's not, you just say that over 2. Now, how do we half a fraction? Just multiply the bottom number by 2. So it's going to be 3 pi over 4. Now, isn't that what we said earlier? Okay. So if you want to, you can just take the period and divide it by 4, and that tells you what each unit is. Now, this is where this throws a lot of people off right here, okay? This is 3 pi over 4, so the next one is not 4 pi over 4, okay? If this is 3 pi over 4, the next one would be 6 pi over 4. Now, isn't that really the same thing as 6 pi over 4? 6 pi over 4 is 3 pi over 2, okay? Do it again. 3 pi over 4, 6 pi over 4, 9 pi over 4, all right? So 3 pi over 4, 6 pi over 4, 9 pi over 4, 12 pi over 4, which is 3 pi, okay? So a lot of times when this is just like, if this was just pi over 4, it's pretty easy. So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, okay? So, but when you have like a number there and that coefficient on pi, you got to count by that number. So it's like 3, 6, 9, 12, okay, over 4. All right, now, amplitude is 1. Now we're ready to graph it. All right, so let's see, we're graphing a sine curve. Now, it's negative. So where do we start? Origin. Sine always starts at the origin, whether it's negative or positive. Okay, right. So normally we say it goes up, but since it's negative, it's going to go downwards. Here we go. All right. Do y'all want to go through this with the calculator? Yeah. All right. All right. Let me get it punched in here. So we do negative sine. Now, the way you can do 2/3, you can use your fraction template. That's like the alpha F1 thing. Or it's just quicker just to say 2 divided by 3. Okay, same thing as 2/3. And then x. Okay, now we got to set the window. Now one thing about it, if you didn't calculate the period right, or if you didn't calculate each unit right, then it's just not going to work out for you. All right, so tell me what I need here. My min needs to be 0, is that right? It started at 0. Okay, now what about my x max? That would be my y max, would need to be 1. See, x is, right, 3 pi. And when I punch it in, it's just going to change it to a decimal. All right, now what about my x scale? So that's, what am I counting each unit by? 3 pi over 4, okay? 3 pi over 4. The x scale. So that's, what am I counting by? Normally when I do graphs, I count by ones, don't I? But, all right, we're counting by 3 pi over 4. So the default is to put 1 right there for the calculator. We're doing trig graphs, so it's usually in terms of pi. Now, my y min and max would be -1 and +1. Okay, now I'm just go to the graph. Okay, it should match up with what I got there. And when I invent my calculator is going to label that. It's going to put 3 pi over 4 on there. Because my calculator is going to be awesome. It'll be a touch screen too. Yeah, go ahead. All right, on number 9. Okay, so You need to calculate the period. She's asking on number 9, what's each unit going to be? All right. So when you calculate the period, you're going to say 2 pi divided by half. This will be 4 pi. So half of 4 pi is 2 pi. Half of that's pi. So you're going to be counting by pi. It's not in radians. Okay. It'd be 1 pi, 2 pi, 3 pi, 4 pi. Okay. All right. Mm-hmm. After that's 3 halves. So 3 halves, 6 halves, 9 halves. Okay. All right. What other ones y'all want to do now? All right. Any other ones y'all want to do? Nope. Okay. Y'all did much better than second period. They just were falling apart. The amplitude is like how high the curve is going to go or how low. So that's really what you're going to put on your y-axis. Okay. So if my amplitude is like 5, then it's going to go up to 5 and down to -5. Right. Right. Uh-huh. So your amplitude would still be 5, but then it would just be a negative sign graph. So, right. Mm-hmm. All right. Any other questions? All right. Now let's do this. All right. I'm going to switch over because I'm going to get rid of the calculator. We don't need it anymore. All right. Now, we're going to graph today secant and cosecant, okay? We'll look at graphs of y equals secant theta and y equals cosecant theta. Now, here's the bottom line. If you can graph cosine and sine, then you can graph secant and cosecant. Okay? But you got to be able to graph sine and cosine first correctly. But if you'll graph sine and cosine correctly, then you'll be able to graph secant and cosecant probably without any problems. Okay? Now, here's what we're going to look at. So why do I say that? So how is secant and cosine related? Well, reciprocal. Right? So opposite's not really the correct term. It's really reciprocals, but I know what you mean, okay? So yeah, secant is 1 over cosine, because that would be the reciprocal of cosine, right? Cosine over 1, the reciprocal would be 1 over cosine. Now, so let me ask you a question here, okay? And this is really what fuels what the graph looks like, all right? What happens when cosine is equal to 0? And I'm probably not phrasing that right. What happens to secant, okay? What happens to secant? It's undefined, okay? Now, let's go back to this. I'm going to go aside just a second. And I did it on the board, but I got to do it under here so my baseball players can see. All right, so just to the side, just watch just a second. When we have like this graph, all right, where is that graph? What value of x is that graph undefined at? 4. Okay, so what happened on the graph at 4 right there when it was undefined right there at 4? X can't be 4, right? So it could go up to 4, but it couldn't touch it. We do this. Right. It was an asymptote, right? So at x equal 4, it's going to be an asymptote because when x equals 4, it's undefined. Now, so we did that back in like, October or something, right? We talked about asymptotes and what the graphs look like. All right. So now let's transfer it to this. All right. So y'all said, well, what happens when cosine was 0 is that secant is undefined. Okay. Now, let's interpret that in terms of the graph. So what happens on the graph when secant is undefined? We have an asymptote. All right. Now, so here comes the big statement. All right. When cosine is 0, secant is undefined. So secant will have asymptotes. And let me explain a little bit better about when cosine is 0. All right. So cosine is 0 where the cosine curve crosses the x-axis, right? All along the x-axis, x is 0. So when it crosses the x-axis, secant will have asymptotes. You can write yourself a little note right here. Cosine 0, okay? That's where you're crossing the x-axis. All right, so I want y'all to visually think about cosine, the cosine curve, okay? All right, what does the cosine curve look like? It starts up where? At just the plane cosine. It starts up at 1. Okay, so whatever the amplitude is, it starts up at that number. And then what does it do after that when it's at 1? It goes down to 0. So when it goes down to 0, when it crosses the x-axis, that's where secant is going to have an asymptote, right? Okay. Now after it crosses 0, it goes down to -1, and then it crosses the x-axis again. So it's going to have another asymptote. So every time the cosine curve crosses the x-asymptote, crosses the x-axis, secant will have an asymptote. Okay. Now let's graph secant now. Okay. Let's look at the graph. Let's do y equals secant theta. Okay. Now, what I'm going to do here to graph all my secant graphs is I'm going to graph the cosine version. Okay. Now notice I'm doing the cosine version in pencil because I'm going to get rid of it in a second. Now, amplitude, period, all that stuff's still going to be the same. Amplitude here is just going to be 1, period is just 2 pi because we don't have any coefficients, do we? Okay, so it's just plain Jane. Now, let me draw that graph. All right, period of 2 pi. So 1, 2, 3, 4. Now let's half. So what's half? Half of 2 pi. Pi, and half of that would be pi over 2. So we're counting by pi over 2. So pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Okay. Now, amplitude is 1. All right. Now, I'm going to do my cosine graph in pencil because later on I'm going to erase it to get the secant one split tray. All right. So where does I'm doing this one now, not this one. Where does cosine start up at? At 1. Okay. And then it goes to 0. All right. And then down to -1. And then back to 0. Back up to 1. Okay. Now I'm going to graph secant. Okay. Now what drives the secant graph is where the cosine graph crosses the x-axis. Where the cosine graph crosses the x-axis, that means cosine would be 0. And what happens to secant when cosine is 0? Undefined, so it's an asymptote. So everywhere it crossed, my cosine curve crosses the x-axis, I'm going to have an asymptote. So how do we draw asymptotes on graphs? Just what? Dotted lines. Okay, and they're vertical asymptotes. So it'll be dotted vertical lines. All right. Now, what do we do to asymptotes? Chase them, right? Okay. Now, all you have to know is how do I chase them? All right. So this is really important statement. The way you chase the asymptotes is you have to chase away from the cosine curve. Okay. You chase away from the cosine curve, so you never cross in the cosine curve. Now, where do I chase them from? You chase them from the min and max points of the cosine curve. Now, where are the min and maximum points of the cosine curve? In -1 and 1, right? So y'all see what this would be a max point there. This one would be a minimum point, and this one would be a max point. Okay, so from those points, the min and max points, we chase the asymptotes. Now, which direction do I chase? So do I chase it like up or do I chase it down? I chase away from the cosine curve. So where would be away from the cosine curve, up or down? Up. So I'm going to chase it up there. All right, now let's go to the min point down here. So how would I chase these asymptotes from the min point? Down. So what the maximums are going to chase up, the minimums are going to chase down. All right. Really didn't space it out too evenly there. And we'll chase this one. So really what would happen if we kept going, the next unit would be an asymptote, and I would get like a full curve right there. Same thing over here. The next one would be an asymptote, so I would be chasing up like that. All right. Yes, because that's going to help you tell where your asymptotes are and where your min and max points are. Now, so that's not my secant graph because I got too much in there. So now we'll go back, and I'm going to erase my cosine curve. But see, I got to draw that cosine curve before I can figure out what the secant graph is. Now, there's my secant graph. Yeah, it's like too much stuff. Okay. Now, I wouldn't like completely mark your problem wrong if you left it in there. Okay, but you would be counted off for leaving it in there. Okay. So what I tell you to do here is when you draw cosine, I should have said this from the beginning, is you draw it very lightly. Okay, draw it real light. Okay. Now, yes. All right, the asymptotes is where the cosine curve crossed the x-axis. Right. Wherever the cosine curve crosses the x-axis, I'm going to have asymptotes. Right. Okay. Now, once you kind of get the relationship with secant and cosine and how you graph cosine to graph secant, now you're going to be able to graph cosecant. So guess what's going to help you graph cosecant? Sine, because cosecant and sine are reciprocals. All right. So now let's graph cosecant. All right. Here we go. Let's do y equals cosecant theta. So now what's going to help me graph it is the sine graph. All right. Now, I'm not going to write out the other stuff. What we should know that the amplitude will be 1, and then the period is going to be 2 pi. Okay. So I'm going to go straight to the graph. Here we go. 1, 2, 3, 4 periods, 2 pi. All right. Half of that's pi. Half of that's pi over 2. So you got pi over 2, 2 pi over 2, 3 pi over 2. Yeah. Amplitude is just 1 and -1. All right. Now, so I'm going to do in pencil here my sine graph. Okay. what does the sine graph look like? It starts origin, okay, and goes up. Okay, here's the sine curve. That's like the worst sine curve I've ever drawn. I can do a good job there. All right. Now, let's see if you can kind of fill in the blanks here, okay? Where sine is 0, where's sine 0 on my graph? Okay. 0 and pi and 2 pi. Sine is 0 where it's crossing the x-axis. Where sine is 0, cosecant will be, you're going to get ahead of me. Where sine is 0, cosecant will be, somebody said it, undefined. And when it's undefined, on the graph now, I will have asymptotes. So wherever I cross the x-axis, my cosecant graph is going to have asymptotes. Okay, so let's draw asymptotes where it crosses the x-axis. So we'll have one at 0, and then one at pi, and then one at 2 pi. Okay, now what do we do to asymptotes? Chase them. Where do we do it from? Min and max points. I got a max there and a min there. All right. How do I chase them though? Up or down? Well, you just chase them away. Yeah, maximum goes up, minimum chase down. Okay. So we're going to chase from the maximum here upwards, chase those asymptotes, and then downwards from here. Okay. Now what? Erase the sine curve. Okay. Now, let's talk about checking this so much on the calculator. Now, I really don't want to show you how to graph secant and cosecant on the calculator. So what I'm going to tell you to do to kind of, let the graphing calculator check you a little bit is let the calculator graph the sine or the cosine graph. Check your sine and cosine graph before you do cosecant or secant. Because if you miss the sine and cosine graph off the calculator, then of course you would miss the secant or the cosecant graph. Now, let's look at some actual examples. All right, these are the basics. Let's look. I'm going to do this one here. Now, this is, you have on the back of the worksheet, you have graphing and secant and cosecant problems. And I'm actually going to do some even ones off of that. Okay, you don't really have to look there, but this is just where I'm getting my examples. All right. So on number 32, it has you graphing here y equals -3/2 times cosecant of x over 4. So it's nice and loaded with fractions. Okay. So I kind of regret yesterday not giving you enough examples with a lot of fractions, because I think that kind of threw you off on the homework. Now, so what I'm going to do to graph this is I'm going to graph the sine version of this graph. Okay. So what I'm going to graph first here in pencil is going to be -3/2 sine of x over 4. I'm going to graph that one first. Okay. Now, amplitude, period, I mean, really none of that's going to change. Okay. Amplitude is going to be what here, guys? 3/2. Okay. Period is 2 pi over b. Right. Now, this is kind of challenging here, but what's the b value? It's not 4. It's 1 over 4, 1/4, because what? X over 4 is the same thing as 1/4 x. Okay, so the b is 1/4, so we'll get 2 pi divided by 1/4, which is 2 pi times 4 over 1, so it's going to be 8 pi. So if I split 8 pi into 4 equal intervals, what's each interval going to be? Huh? Be 2 pi. If I take 8 pi and split it into 4 equal intervals, 8 pi divided by 4 would be 2 pi. Okay. Now, we're going to use the half strategy anyway. Okay. All right. So we go 1, 2, 3, 4. So 8 pi is the period. Half of that's 4 pi. Half of that's 2 pi. So every unit is 2 pi. 2 pi, 4 pi, 6 pi, 8 pi. Okay. Now amplitude is just 3 halves. It's going to be like 1 1/2. Okay. Now, so what we're going to do to get this cosecant graph right there is we're going to graph the sine graph first. Okay. Now, so help me sketch in the sine graph. Now notice it's negative. Okay. All right. So where's it going to start? Origin, and go down because it's negative. All right. So let me sketch it in. All right. Now, what I would do here, if I was on my own doing problems by myself, I would throw that in the calculator, okay, and check my sine graph, okay, because if my sine graph's not right, I'm going to miss my cosecant graph. So that's the check on these. It's not to really check this graph, but to check this graph on your graphing calculator. All right. Now, so how do we graph cosecant? Well, where sine crosses the x-axis, cosecant, what's going to happen there? Undefined, which means asymptotes. Okay, so we're going to have asymptotes at 8 pi, 4 pi, and 0. All right, now what do we do to asymptotes? Chase them. Okay, and we're going to chase them from the min and max points. And so the minimum point we're going to chase downwards. Max points we chase up. All right, and what else we need to do there? Erase your sine curve. Okay, that's a pretty one right there. All right, let's do another one. This time, all right, that was a cosecant. Let's do a secant one. Let's see. Let's do number 40, okay? All right, so this one's a secant one. Here we got negative 3 halves. So same kind of like the other one started. All right, let's do secant of pi x. So what's really going to get this graph is, what graph am I really going to do first there? Cosine. So y equals negative 3 halves cosine of pi times x. So this is the one I'm going to do in my calculator and check out first. Okay, yes. Doesn't matter because it's the same. Okay. All right, so amplitude and period, I mean, it doesn't matter what you look at because all the numbers are still the same. Right, you wouldn't really do this one until you got ready to graph. Okay, and you don't have to write it out, is what you're saying. All right, so amplitude, all right, go ahead. Hang on. Now they were both negative. Okay, you probably just missed copying down that negative side. All right, help me out here. Amplitude. There's 3 halves. Okay, no negative because it's absolute value. All right. Now, period. It's 2 pi over b. What's the b? Pi. All right. So the pi's would just cancel. So it'd just be 2. Okay. So this time my period is not in terms of pi. All right. Let's graph the cosine curve now. So here we go. 1, 2, 3, 4. This is going to be 2. Half of 2's 1, half of 1's a half. So every unit's a half. 1 half, 2 halves, 3 halves, 4 halves. All right. Amplitude, we got just 3 halves. Okay, so before we graph secant, let's graph cosine. All right, so we're doing that's a negative cosine graph. So where's it going to start at? Yeah, right, -3/2. And then from there it has to go up. So, all right, it's going to go to 0 there at 1/2. And then at 1, it's going to go up to 3 halves. 3 halves is back to 0. And at 2, it's down to -3 halves. All right. So now, when you do this, you probably want to do it like, very, very light, so it'll erase in a minute. All right. So now, where my cosine curve crosses the x-axis, it's going to happen asymptotes. Okay. Undefined, yeah, which means asymptote. I always do the opposite, yeah. So undefined and asymptotes, same difference. That's what they mean together. Okay. I know, I'm always like messing with you. All right. And now, what do we do to asymptotes? Chase them. I thought somebody would say take them to orange leaf. Yes, it's good orange. All right. All right. We can take our asymptotes to orange leaf. Get orange leaf too much, your asymptote gets pretty big. All right. Now, erase it, right? No. Okay. So if you can visualize your cosine curve, because I'm not going to be, when I'm grading your problems, I'm not going to grade your cosine curve in. Okay. So you don't have to draw it. If you can visualize what it looked like, okay? And yeah, that's fine. If you want to do like, you do your cosine graph in a pencil, and if you want to do the other in a pen so it stands out better, you can do that. All right. Now, all right, I want y'all to do this one here. Let's go ahead and start. You've got, all right, on the back side of this, 29 through 39, these odd problems here. Okay, so let's do this. Let's pick one that you can do in class and check on. Let's try to find a difficult one. Yeah, that's probably a good one. All right. Go ahead, skip to 31 first. All right, you're supposed to do just the odds from 29 to 39. All right, go ahead and do 31 first. Okay, and I'll walk around and check on everybody.